Imagine lying in bed, drifting off to sleep, and waking up with the answer to a problem that eluded you for months. It might sound mystical, but throughout history, many innovators have claimed just that: breakthroughs emerging directly from dreams. Could dreams be more than random neural firings? Could they serve as a hidden engine of creativity and even innovation? Let us begin with the most famous case. Friedrich August Kekulé, the 19th century chemist who discovered the ring structure of benzene. Kekulé reported that he had a vision in a half-dreaming state of a snake seizing its own tail, the ancient symbol of the Ouroboros. That image helped him conceptualize the benzene molecule as a closed ring, solving one of the great puzzles of organic chemistry. Now ask yourself, how could such a symbolic image encode a deep molecular truth? This is where the idea of dream incubation enters. Dream incubation is the practice of consciously thinking about a problem before sleep in hopes that the subconscious mind will continue working on it overnight. While modern science still debates the mechanisms, many researchers agree. Sleep stages like REM and hypnagogia, the twilight phase between waking and sleep, are rich in nonlinear associations, pattern recognition, and emotional insight. Other notable inventors and thinkers have tapped into this dream innovation connection. Dmitri Mendeleev, creator of the periodic table, said he saw the table's arrangement in a dream after weeks of frustration. Elias Howe, inventor of the modern sewing machine, reportedly dreamed of being attacked by warriors with spears that had holes near their tips, leading to his breakthrough in needle design. Salvador Dali and Thomas Edison both used micronaps with metal objects in hand, waking up as they dropped them, capturing dream images just before they vanished. Why might this work? One hypothesis is that dreams allow conceptual blending, the fusion of seemingly unrelated ideas in a symbolic or abstract form. This blending bypasses the prefrontal cortex, which during waking hours suppresses unconventional ideas in favor of logic and linearity. In dreams, the brain's filters are relaxed, allowing novel connections to emerge. How can one actively use dreams for innovation? Here is a practical method used by artists, scientists, and lucid dreamers alike. Intention setting. Before sleep, focus your mind on the problem or idea. Write it down as a clear question. Hypnagogic awareness. Observe images and thoughts as you fall asleep. Keep a voice recorder or notepad nearby. Dream journaling. Upon waking, write down whatever you recall. Even vague impressions can hide useful metaphors. Reflective mapping. Try to interpret the dream content in light of your waking problem. Ask, what patterns or metaphors appeared? Could they point to real solutions? Modern neuroscience supports this. A 2020 MIT Media Lab experiment used a wearable device called Dormio to guide people into hypnagogia, feeding them audio cues while they drifted off. Participants who received cues related to creative tasks showed increased originality in problem-solving exercises compared to controls. Har, Horowitz et al. 2020 Consciousness and Cognition. Even tech companies are exploring it. Google engineer Michael Nielsen has spoken about dream-aided design, and researchers are investigating how AI might one day stimulate targeted dream content to enhance creativity. Could this be the future of innovation? Dream incubation is not a magic formula, but it may open access to pre-verbal or intuitive intelligence, often ignored in data-driven systems. When structured properly, it becomes a soft technology of the mind, offering a radically different channel for insight, one that operates at the edge of consciousness. So next time you are stuck on a difficult problem, consider this. Perhaps the answer is not in another book or experiment, but waiting quietly somewhere inside a dream. Would you like a guide to modern techniques of hypnagogic problem solving or a list of inventions linked to dream experiences? Throughout history, several prominent scientists and inventors have attributed major breakthroughs to dreams. These accounts suggest that the subconscious mind can reorganize known information into novel insights during sleep. While anecdotal, These stories align with what cognitive science reveals about memory consolidation and creative association during dreaming. Such dream-driven insights often involve symbolism, metaphor, or abstract visualizations that must be interpreted upon waking. This supports the idea that the brain remains highly active in problem-solving even while unconscious. Friedrich August Kekulé dreamt of a snake biting its tail, which led to his realization of the ring structure of benzene. Dream-driven discovery is like a puzzle solving itself while you sleep and showing you the finished picture in the morning. During REM sleep, the brain shows high activity in the associative cortex and limbic system, while the prefrontal cortex, the seat of logic and filtering, is less active. This shift enables freer connections between disparate ideas, potentially allowing for novel recombinations. These patterns support lateral thinking, metaphor generation, and insight formation. The brain essentially experiments with reorganizing memories and unresolved problems in a creative, unfiltered space. Neuroscientific studies confirm that dreaming promotes insight and problem solving under certain conditions. EEG studies show bursts of gamma waves in REM sleep associated with moments of insight and high-level cognition. The dreaming brain is like a jazz musician improvising, breaking rules to find new harmonies. Activity. Incubation refers to the phenomenon where stepping away from a problem enhances the chance of a solution later emerging. Dreaming is considered an extended form of incubation, allowing the subconscious to work without interference. Experimental psychology has demonstrated that people often solve complex tasks better after sleep. This supports the idea that nonlinear, unconscious processing may play a critical role in creativity. During sleep, irrelevant or constraining assumptions may be weakened, freeing new pathways for thought. In one study, subjects were significantly more likely to solve a number-based logic puzzle after a nap. Letting your mind wander in sleep is like letting a computer process in the background while you focus on other tasks. Research by Deirdre Barrett and others shows that people can dream about specific problems by focusing on them before sleep, a process called dream incubation. Participants who tried this were significantly more likely to dream about the problem, and some even solved it upon waking. This demonstrates that dreams are not entirely random, but can be guided toward useful content. Problem-focused dreaming taps into emotional salience and pattern recognition processes embedded in memory. The dream's content may appear abstract or metaphorical, requiring interpretation. Students told to dream about a science problem solved it 30% of the time in sleep studies. Incubating a dream is like programming a question into a search engine that runs while you're unconscious. Dreams often communicate insights not in literal terms, but via symbols, archetypes, and metaphors. The language of dreams resembles myth, visual poetry, or narrative logic rather than equations or data tables. For scientists, interpreting such dreams requires translating symbolic content into formal conceptual understanding. Many discoveries reported from dreams involve a moment of recognition upon waking, when the metaphor's meaning becomes clear. This symbolic nature aligns dreams more closely with creativity and intuition than deduction. Dmitry Mendeleev claimed the structure of the periodic table came to him in a dream, arranged like a chart. A dream insight is like a parable. You have to decode its deeper meaning to understand the message. Dreams are shaped not only by recent thoughts, but also by deep emotional and motivational patterns. This emotional salience ensures that problems of high personal or intellectual value are more likely to be processed in dreams. Brain regions like the amygdala and hippocampus are involved in both memory consolidation and emotional tagging. The result is that emotionally important scientific problems may recur in dreams until a resolution is found. This mechanism can elevate creative urgency during sleep. Artists and scientists report repeated dreams about unresolved works, often feeling emotionally compelled to solve them. Emotional importance in dreams is like a spotlight in a dark room. It guides your unconscious attention to what matters. Controlled experiments in sleep labs now allow dream recording, content analysis, and even targeted memory reactivation using sounds or smells. These techniques help researchers assess whether problem-solving insights correlate with specific dream content. Dream journaling is a validated tool to increase recall and enable later analysis of symbolic clues. There is also emerging interest in lucid dreaming, where individuals can interact with their dreams to consciously explore problem-solving scenarios. Although still early, these methods show the feasibility of using dreams as a cognitive extension of waking thought. Lucid dreamers have performed mental arithmetic and reported solutions while dreaming, verified post-wake. Modern dream science is like training a telescope to study an inner universe of thought. If dreams contribute meaningfully to innovation, this challenges strictly rational models of discovery. It implies that creativity may emerge not from linear thinking, but from nonlinear, unconscious cognitive processes. This intersects with theories of dual process thinking, where intuitive and reflective systems interact to produce breakthroughs. It also suggests that consciousness extends into states previously considered passive or irrelevant. Thus, the dream state may serve as a hidden partner in the creative process. Otto Lowy's Nobel-winning idea for neurotransmission mechanisms came from a dream experiment. The mind in dreams is like a shadow research lab, working on solutions when you least expect it. Modern neuroscience and historical evidence both support the idea that dreams can meaningfully contribute to innovation. While not deterministic or universal, dream incubation appears to enhance the creative process by enabling free association, emotional integration, and symbolic thinking. It cannot replace scientific rigor, but it can complement analytical reasoning with intuitive insight. For inventors, artists, and scientists alike, cultivating the dream state may unlock otherwise inaccessible perspectives. Encouraging intentional dream recall and analysis could become a tool in the innovation toolkit. Thomas Edison reportedly used microsleeps to capture hypnagogic visions, which he then translated into inventions. Dream incubation is like an idea garden, planted at night, growing unseen until it blossoms at dawn.